So from today onwards, I am starting module 3. Okay, first chapter I will finish first chapter today itself. Okay, second chapter will start from tomorrow. Now, third module is all about first and second module is all about your ARM processor. Okay, so first chapter is completely theory about the ARM processor. Second module is completely about instructions, various ARM instructions. Now, I hope you might have seen first and second module for exam. So it will be easy if you plan properly. Okay, it will be very easy if you plan properly. Now in module 3, 4, 5, they have discussed embedded system. Now, what is the relationship between embedded system and first two modules, that ARM processor is? ARM processor is the one of the processor, I can say very dominating processor in embedded system. So if you open any embedded system, you can find ARM processor in it. Okay, so whereas other processor, full sophisticated processors like Intel, Motorola, AMD, these processors are very generic type. Okay, they are used in desktop applications, laptop applications, basically in a computer system. Okay, but they are not preferable to use it in embedded system. Okay, that's why your ARM processor is very cheap. You can it is available from 2,000 rupees. Okay, it starts from 2,000 rupees your ARM processor, whereas your Intel processors definitely start from 15 to 20,000 rupees. So that is the difference. Okay, so now what is, before starting introduction to embedded system, so according to your syllabus, it starts from they have skipped the first part, what is embedded system. Okay, in your textbook there is a one paragraph, what is embedded system. Now majorly I hope you can understand what is embedded system. The word embedded in the sense made up of different parts. Okay, your cycle is an embedded system. In general, for example, I consider a cycle is an embedded system because it is made up of individual parts like a tire, two different tires, right, and body, right? But it is not a pure embedded system. Okay, why? Because if you detach everything, they individually do not have any scope, right, or any meaning. So you just a steering without anything, and you cannot call it a cycle, right? Or simply a tire. Okay, what can you do with a cycle tire? Simply a cycle tire. It is useful only when it is attached to entire embedded system called cycle. Now, what is embedded system? Very simple. Any computer systems should not call it as a computer system. Any system which are made up of different parts. Your textbook may have a varying different definition. Okay, for the exam purpose, you go through the textbook itself. But now, what is the use of, you might ask, any computer system, if you open your laptop, there are different parts. The laptop is made up of different parts. So is it an embedded system? No. Embedded system has one more very important point in the definition. Embedded system is not just a collection of different parts or a system with different parts, but also, okay, it do not require a full scale computer system in order to run. Did you get this? It is not a full scale computer system. Okay, for example, let me give some example for your embedded system. Your smartwatches, you might have right, you have a smartwatch with you. The smartwatch, do you need a computer system to run? Do you need that smartwatch to be connected to a laptop or desktop in order to run the program, or in order to run that smartwatch? It runs itself, right? Smartwatches do not require any help of any full-time computer system. So embedded system, let me clarify my definition. Embedded system is a system made up of various different parts, okay, and can run or perform its task what it is made for. It can perform its task without the help of full-time computer system or full-scale computer system. So your car system is an embedded system. Nowadays your calling bell, a calling bell is an embedded system. Yes, right. When nowadays calling bells are very sophisticated. If you press calling bell, right, it has very customized ringtones, right? And morning it gives a different ringtone. Evening it gives different ringtone. Night it will give a very pleasant ringtone. How do that calling bell right, behave in that manner? Because it's an embedded system. There is a processor inside it. Okay. Now, so there are a lot of embedded systems. We'll study. This chapter is only about embedded system introduction. Okay. This chapter is only about embedded system introduction. So let me go to introduction part here. Okay, this is a definition. What is the embedded system? Of course, it is an electric, mechanical system, electrical or electronic or mechanical system. It depends on what parts an embedded system includes. Okay, for example, your car AC system. In a car, there is right AC system. In a very luxurious car, you can handle that entire AC using a touch screen. Okay, or in some system car you can handle your AC using manual buttons. It's an embedded system. But AC is a mechanical, right? There are some mechanical parts which require to vary the temperature. So it's either electronic system or mechanical system. Your smartwatch is complete electronic embedded system, right? Your car AC system is electromechanical system. So when I say mechanical, I hope you can understand the concept. Your calling bell is a simple electronic embedded system. Okay. Nowadays you can find smart fans, right, with the remote system and automatic speed adjust. It's an electromechanical system. Next is yeah, of course, what is difference between embedded system and a full-scale computer system? So full-scale computer system like your laptop or desktop, they are very generic. Generic in the sense they are designed for general purpose. Using that you can execute any code, you can execute any application, right? You can use your computer or laptop systems which are full-scale computer systems for general purpose. So it is generic. Whereas your embedded systems are very customized. They are designed for specific function. Right? If there is an embedded system for your calling bell system, you cannot use it in your refrigerator. Okay, refrigerator is another embedded system. Your micro oven is one more embedded system. The simplest embedded system is a bread toaster. Right? When you put some bread in the toaster and turn it on, it automatically turns off and bread pops out of the your toaster. So that is a complete embedded system. It's completely almost electromechanical computer system, right? There will be motors, right? So this is electromechanical system. Your oven, refrigerators, AC systems, everything is a embedded system. The highest embedded system which has occupied most of the persons or many you having highest users, that embedded system is your mobile cell phones. Okay, cell phone in the world is the one embedded system which is used by many people. Your mobile system is not a full-scale computer system, and even if you open your mobile system, you might have seen what are the name of the processors of a mobile system before purchasing it. The processor is not a full-scale processor. If you plug out your processor which is there in your mobile, Android mobile, okay, you cannot insert it in desktop or laptop and use it as a full-scale processor for various general purpose. Okay, that's because it has a limitation. The CPU or processor inside your mobile is made for some limited purpose. So your mobile system is an embedded system, right, which runs on your battery, camera, sensors, all are different embedded system parts. Okay, what is the purpose, specific function of the mobile system? Communication. Communication is a specific function initially. Now mobile has some very special functions, but still, okay. Your mobile system is an embedded system, micro oven, refrigerator, AC. Most of the systems you see, calling bell, even in vehicles, right? Your AC regulators, automatic headlight adjustments. Nowadays you can find automatic headlight adjustment, brightness adjustments. Especially your stereo system in the car, all are embedded systems. And nowadays you can see automatic vehicles self-driving cars, right? Car do not require manual driving. Okay, it automatically drives you. So such cars are completely a very sophisticated embedded system. The entire car itself is the embedded system. Okay, so they are designed for specific function. When you buy a laptop, if you ask what is the purpose of the buying a laptop, you can have various purpose, right? Watching movie, entertainment, or running specific applications, designing and development of applications, lot of or office purpose. But when you purchase an embedded system, nobody will ask what is the purpose, because they are already designed for a particular purpose, right? When you going to buy a calling bell, nobody will ask why you are buying a calling bell. Definitely you are buying a calling bell for a specific purpose. When you buy a smartwatch, you are buying it for a specific purpose. Whereas even your headphone, earphones are also wireless earphones, wired earphones also embedded system. They have their own processor inside it. And I told you 99.99% of market share in embedded system is actually ARM. ARM is having ARM is there in inside almost all embedded system. If I ask what is your what's the processor you have in your Android mobile, you might tell me that a Snapdragon or ATX. There are a lot of processors, right? Most of the processors are Snapdragon processor. Now, which all these are ARM processors itself. Okay, I don't know whether you know it or about this. There is no ARM processor available in the market. Okay, if you go to market and ask someone give us a Intel processor, they will give you Intel processor. You can find a Motorola processor. You can find a AMD processor. Okay, even though they are having different versions, but you will get a processor, Intel processor, AMD processor. Can you buy an ARM processor in the market? There is no ARM processor. Basically, does not exist. Okay, the what do you call whatever you have studied in first two model, the ARM is a design. ARM is a design. Now various different companies buy that design and manufacture the processor in their name and sell it to the bring it to the market. So when I say Snapdragon processor, which I have in my Android mobile, it is an ARM processor. The processor is designed by designing means what? Right, preparing a processor on the paper, right? On a paper. Paper is design. They are designing the functionalities of the processor. They are designing circuit of the processor and functionality of the processor, but they never manufacture it. Okay, they design various ARM versions. I will buy one ARM version and manufacture myself, and I call it a Snapdragon. Yes, there are a lot of LPC21 LPC processors are there. Famous processor LPC designed by Philips. Okay, but what is that? It is actually ARM processor because design is ARM. So always remember, there is no processor called ARM in the market. It is just a design on the paper. Okay, various different companies buy that design and they actually manufacture. So the person who actually manufactures, company who manufactures, name it in the, okay, sell that processor in the name of that company. Okay, like Snapdragon or LPC by Philips. This is a concept. So more 99% of embedded systems actually have ARM processor inside it, even though it is manufactured by various manufacturers. So what is embedded system? Is the electromechanical system with specific functionalities, right? Specific functionalities, and it will have both hardware and generally we call it as firmware. Okay, we call it firmware. Please go and find out what is the difference between software and firmware. Okay, or in general we can say it will have hardware and software. Okay, the software designed for specific function. Okay, so next, so yeah, so every embedded system is unique, right? Of course, every embedded system is unique. They are designed for specific purpose. You cannot compare your calling bell system with your refrigerator embedded system. Okay, or refrigerator with your oven, micro oven embedded system. Every embedded system has its own purpose. The parts inside it, components of embedded system, the software written inside that embedded system, the processor, and the purpose, everything is different. Okay, when you compare different embedded systems. Okay, whereas you compare generic computer systems like laptop and computer, they all have similarities, right? Every laptop or desktop you compare, they have similarities. Okay, input output devices, hardware, that's the thing. Okay, then hardware as well as the firmware is highly specialized to application domain. Okay, your hardware, whenever we place components inside an embedded system, which components we have to place, it completely depends on what embedded system it is or why it is made for. Okay, so that's what I'm saying. If you open a micro oven, you will find different components, whereas when you open a refrigerator system, you can find different components. The hardware are completely different. Okay, they're specialized to their application domain where you're applying, right? So even software, firmware is also different. Okay, code is written for different purpose. Okay, the code which you actually executes cooling system in a refrigerator, you cannot copy and paste it in a micro oven, or you cannot copy and paste it in a car stereo system. Purpose is bare, specification is bare, right? The functionality is different. The next point is Yeah, embedded systems are becoming an inevitable part of any product or equipment in the field of yeah, in every field now by now you know what is the embedded system. You can easily identify embedded systems. Okay, these are electronic small electronic systems which have microcontroller or microprocessor inside it. Okay, so now everywhere it is there in right our day-to-day life we make use of lot of embedded systems. Okay, like household appliances I told you, AC, TV, refrigerator, television, refrigerator, micro oven, AC. Okay, calling bell. Then telecommunication systems, your mobile phones, right? And medical equipments. Yeah, you can find lot of small screen devices in ICU or hospital, right? Even now you can find digital blood pressure measurement systems. All are embedded systems. Okay, industrial controls, right? You can control big machines automatically. They control themselves based on some input data using sensors, right? All those industrial equipments which works automatically are basically individual embedded systems. Even consumer products. So there are embedded systems is there in everywhere, right? Most of the products which we were using manually or some very old electronic systems now have completely replaced with embedded systems. Now second part of the this module actually discusses characteristics of embedded system. Okay, it's very hard to remember. There are a lot of characteristics. The only thing you can do is you understand what is embedded system. Then you can keep remembering all those things, right? So here some points we have noted. Embedded system is highly reliable and stable. Okay, highly reliable and stable. Stable in the sense it do not changes, right? We do not keep changing its software or hardware. Right? Do you remember what is the last time you modified your calling bell? Right? Either we buy new one, right? Or only thing we change is the cell, right? Battery cell. We do not open a calling bell. We do not open a micro oven. Have you ever brought your micro oven to any showroom and asked for update it? You cannot update it like a mobile phone software or desktop softwares, right? Yeah, their software or hardware inside a embedded system is always stable. Okay, so it do not change, and they are highly reliable. Okay, because they are designed for specific purpose. We don't keep maintaining it every time, right? ಪ್ರತಿ ಅದು ಓಪನ್ ಮಾಡಿ ರಿಪೇರಿ ಎಲ್ಲ ಮಾಡ್ತಿರಲ್ಲ, so it must be very reliable. It designed in such way. Okay, so that is the thing. Then it has very less or no user interface at all. Okay, very less interface. In the sense, you look at the calling bell. Have you found any calling bell which has a screen? Touch screen or any regular screen? No. Why? It's a minimal interface will be there. Why? Because calling bell do not require a screen at all. Okay, what does calling bell require? It is just a speaker and a button to press, right? When button is pressed, the speaker turns on. Now you might say when there are multiple ringtones, you want to change the ringtone. So how do they provide a separate screen, touch screen to change the ringtones of a calling bell? No, you just check your calling bell, there will be buttons, right? There will be buttons. Okay, if you go and check your digital watch, I'm not talking about a smart watch. You go and check your digital watch, right? If you check a digital watch, you will find 4 keys. Using that, you can change the time and date. Why they have not that? Why they are not giving a separate touch screen for? Because it's not necessary. Means the interfaces are very minimized. ಎಷ್ಟು ಬೇಕೋ ಅಷ್ಟೇ interface ಅನ್ನು ಕೊಡ್ತಾರೆ, like a buttons, multiple buttons or screen. Even you go and check your refrigerators. Even now sophisticated refrigerators, big scale refrigerators have touch screens to vary the temperature and adjust various control. But you have a domestic where the refrigerator you use in your in house, right? Your home do not have any touch screens, like just a button, because a button is enough, isn't it? You are in a AC, a small screen will be given. So user interfaces ಏನಿದೆ ಅಲ್ಲಿ, how user can interact with the embedded system, there will be minimum very required options only. Okay, ತುಂಬಾ minimum options ಇರ್ತವೆ ಅಷ್ಟೇ. Okay, then it is feedback oriented or reactive. Okay, that what is reactive or feedback oriented means, if something happens they will react it, like a calling bell. Okay, most of the time now if you press the button, it plays the ringtone. Means somebody has to press the button. Okay, it depends on input. Okay, most of the embedded system works on input. Okay, even your refrigerator, even if it you are not using refrigerator, it keep adjusting temperature. How? There is a sensor, and based on the feedback of the sensor, what is the temperature, it will adjust the cooling system. So that is the thing. Then one more is yeah, it is designed to meet real-time constraints. Okay, real-time constraints. Of course, right? The embedded system you use in real time, your day-to-day life. Unlike your laptop and desktop, where there is no specific purpose. Here they are used in real-time systems. Okay, like maybe your mobile system, car automatic car systems, or refrigerator system. They are real-time, right? There is a goods in the refrigerator. If it won't work properly, the good gets spoiled, right? Right? You keep something in food in your micro oven. It must work on real time, isn't it? If it turns off 5 minutes later, then your food gets burned out. So that's how, right? Even if your automatic vehicles, right? Self-driving vehicles, right? If it won't right, put the brake at proper time, you meet with the accident. That's the thing, right? They work with the real-time applications, okay? And they will have a very limited memory and peripherals. I told you interfaces are very minimal, okay? A calling wheel will have only speaker, right? A refrigerator will never have a speaker. Very minimum peripherals, minimum components, hardware components are given, which are only required components will be there. Okay, even memory is also very little. Okay, memory, like unlike your laptop or desktop, there will be no 1 terabyte of memory. Memory will be in kilobytes. Okay, so there are various characteristics. Okay, you can go through this. Most important characteristic is last point: low power consumption. They are designed to consume less power. Okay, that's why you change your battery cell of your calling bell once in a year or once in 2 years. Right, your remote cell of a TV itself is an embedded system. Do you know that remote of your TV itself is an embedded system? Okay, so they consume very less power. That's why even if your car is turned off, you can play stereo system. Why? Because it do not consume more battery. Okay, that's some characteristics. Then there is a difference they have discussed here in your textbook as per the syllabus. What is the difference between general computing system, that is desktop system, as well as your laptop, or with the embedded system? Okay, with the embedded system, first thing is the purpose. Okay, your computer system are general purpose. We don't know why what for what purpose we are going to use it. Okay, depends. So you can utilize your computer system for any purpose. Okay, whereas your embedded systems are designed for specific purpose. Okay, and they have discussed different differences here. Okay, so till now I have given what is the embedded system explanation. So the differences you can compare general computer system and embedded system. Then the history of embedded system. Okay, this is completely theory. You go through with the history from almost 1950s. Okay, 1950s till 22, right? To 2010 till there they have discussed how embedded system evolved. Okay, what are the various embedded system you have seen? Basically, they do not ask this for exam, but still it is better if you know the history of the embedded system. Then they have discussed classification of embedded system. Okay, classification of embedded system. Basically, there are 4 different categories. Okay, classification categories. They have classified embedded system based on the generation. They have classified embedded system based on the performance of the embedded system. Then they have classified it based on the deterministic behavior and based on the trigger. Here in the PPT, I have shown only 2 types of classification, based on the generation and based on the performance. But go to your textbook. Okay, in textbook they have clearly mentioned 4 type of. Okay, in the exam they might ask generally explain classification of embedded system, or they might specifically ask explain classification based on the generation or classification based on the performance. Okay, so here there is a classification based on the generation. How first generation, second generation, third generation, and 4th different generations they have discussed of the system. Okay, this is based on the year. Right, 1960s ಅಲ್ಲಿ 1970s ಅಲ್ಲಿ ಯಾವ ತರ ಎಂಬೆಡೆಡ್ ಸಿಸ್ಟಮ್ಸ್ ಇತ್ತು, ಅದರ ಮೆಮೊರಿ ಎಷ್ಟಿತ್ತು, ವಾಟ್ ಇಸ್ ಸರ್ಕ್ಯೂಟ್ ಹಾರ್ಡ್ವೇರ್ಸ್ ಯಾವ ತರ ಇತ್ತು, ನಂತರ 2000s ಅಲ್ಲಿ ಯಾವ ತರ ಬಂತು, 2010 ನಂತರ ಯಾವ್ದು ಬಂತು, ಈಗ ರೀಸೆಂಟ್ಲಿ ರೈಟ್ 2010 afterwards we have smartphone. That's why it is categorized under 4th generation. Okay, 1G, 2G, 3G, 4G don't mention it. Okay, that is just for your understanding purpose. There is not standard keyword. Okay, you have to specifically write first generation, second generation, third generation, and 4th generation. Okay, embedded systems. Based on the generation, there are 4 classifications. Okay, first generation, second, third, and fourth. Okay, so now you can simply compare that as new generation has arrived, its uh, embedded system hardware and software have become sophisticated. That's it, right? More and more complicated. Okay. Then come, I told you second category classifications you have done based on the complexity and performance. How complex embedded system is. Okay, what different components are there? How many number of components are there? How complex its software is, right? How sophisticated its processor inside the embedded system is. Based on that, uh, we have discussed on the complexity and even performance. How fast is that? How fast is an embedded system is. So there are three categories they have discussed. One is a small scale, medium scale, and large scale. Okay, just a 5 minutes. I'll finish this. Small scale embedded system. Okay, used for simple purpose. For example, your electronic toy. Right? They have discussed electronic toy. Or I can say calling bell is also a very small scale embedded system. There will be less memory, very less peripheral devices. The processor we use, even though it is ARM or any other processor, basically embedded system processor is called as microcontroller. It is not called as microprocessor. Okay. Earlier we only had microcontrollers inside embedded systems. Now we have microprocessor because ARM is neither a processor nor a controller. It is in between. So let us merge everything. We call it as a processor itself. Small scale embedded system will have the processor which has very less capability. Okay, very less capability. So calling bell, your electronic toys, even I can say computer stereo system, music player in your car is also a small scale embedded system. Okay. Medium scale embedded system, its purpose is very complex. I mean, it is used for some sophisticated purposes. Okay, it will have complex hardware, more number of hardware components. Its purpose is very important. Okay, it's not a little bit critical. So see some guest errors and press the calling bell. If calling bell is not working, it doesn't matter. He can knock the door and you can open. But a system, embedded system in a hospital, right? Blood pressure checking system. If it fails, it can give wrong readings. Then medication may be different and it may harm a person. It is critical. So small scale embedded system do not have a critical purpose. Medium scale embedded system have somehow medium critical purposes. Okay. Its capacity, hardware capacity is little bit more, processor capacity little bit more. Your code or software inside it, firmware is little bit complicated. Right? It serves a little bit medium critical purpose. Okay, medium scale embedded systems. Like I can say your health related equipments or even micro ovens or refrigerators, televisions, right? Then we have large scale embedded systems which are serve very critical applications. So the second point is a mission critical. Mission critical means such embedded system which fails, it totally causes the purpose of the entire embedded system, right? Okay, for example, your health related embedded system or embedded system in a flight, right? There is a flight will have a lot of embedded systems. Okay, pressure management, altitude management, all those things. Okay, there are a lot of wing angle management. So the flight will have a very complicated. So imagine what is the mission of the flight. Okay, transport person from one source to destination. If one of the embedded system in the flight aeroplane fails, the mission entire mission may fail. Like flight might meet with the accidents. Okay, so that's what I'm saying. Mission critical means what is the mission of the entire embedded system? Entire mission itself may fail. Okay, so that is how large scale embedded system matters. Okay. Okay, two types we discussed: classification on generation, classification on performance and complexity. There are two more complex classification not discussed because they are discussed only very small theory they have given in textbook. One more is classification based on deterministic behavior. Okay, there are two types in under that. One is the deterministic embedded system and non-deterministic embedded system. Okay, so it is nothing but whether an embedded system makes decision itself or it has to depends on someone else. Okay, based on that there are two types of based on deterministic behavior of the embedded system, there are two types of embedded system: deterministic embedded system and non-deterministic embedded system. Then one more classification is based on triggering. Okay, what is triggering? Okay, triggering means see, some embedded system requires So the triggering is basically on real time. Okay, we use real time embedded systems. Some embedded systems are very they are automatic. They do not wait for any event. Okay, some embedded system are event based. Okay, only some event happens, then they work. Okay, for example, calling bell. It works only when somebody press the button. Okay, only when somebody press the button, it works. So there is a triggering. What is pressing the button is a trigger. So embedded system starts working. Whereas your refrigerator is not trigger based. Why? It is not event based. Because it has to keep running. It has to keep reading temperature, adjust the cooling system, reading the temperature, adjust the cooling system. Right? That's all it does. But it keep doing. Okay, it never do you think that refrigerator system works only when you open the door or close the door? No. Okay, but micro oven is a trigger based. Why? When you keep the food and press a particular button, only it starts. Okay, so that's how. Even your aeroplane system, your pressure management, it's a non-triggering, right? It don't wait for somebody to press a button. If pressure is low or higher, it automatically adjusts. So that is based on triggering, means whether embedded system should need a particular event to run or it automatically keep running every time. That's how your music player is a triggered system. Why? Whenever you press some button, when you lower a volume, it lowers the volume. Whenever you change the song, it changes the song. Otherwise, it keep right. It do not work basically, right? So that's how. So systems, embedded systems are based on triggering or non-triggered, whether it's event based or non-event based. Okay. So 4 categories of classification. Please go through it. Okay. Major application areas. Please go through the major application areas. Lot of application is there. Okay, including health and very sophisticated military, day-to-day life, right? Health industries, travel, vehicle industries. Okay, now as I told in my previous slides, it is inevitable. You encounter embedded system in every part of your life every day. Okay, lot of applications. Consumer electronics, like your camera, your refrigerator, home household appliances, micro oven, refrigerator, DVD player, TV, television. Okay, home automation and security system, cameras, right? Okay, your network circuit, the closed circuit, CCTV cameras, automotive industries, right? Computer peripherals, networks, lot of applications are there. Okay, always remember at least 10 different applications of the um, embedded system. Okay, then purpose of embedded system. Okay, the same concept. What is the purpose? What is the various purpose of embedded system? Okay, we design embedded system on various tasks. Okay, that is the purpose. So data collection, storage, then communication, data processing, monitoring, controlling, right? So for example, calling bell, it's a monitoring system. If somebody arrives, right, you can ring a calling bell. Your AC refrigerators are controlling system which controls temperature. Okay, so a lot of your switches or bridge that we use in network system, they are data communication purposes. Okay, you can go to various purpose of embedded system. Okay, complete theory is there. Okay, then okay, this is the end of the first chapter. Okay, this is the end of first chapter.